In this lesson, we're going to talk about energy and specific heat from Wiley sections 3-4 and 3-5. We're going to talk about the relationship between energy and chemistry, types of energy, heat and temperature, endo and exothermic processes, units of heat, and end with specific heat. One of the great things chemistry does for us is chemical reactions produce energy. Energy that is stored in chemical bonds. We get heat, we get light. It's chemical energy that powers our cars. We need chemistry to live. And that statement is particularly valuable because our bodies are heat engines. Our bodies require chemical energy to stay alive. Scientists do what they always do to make our lives better. They define and quantify these different processes. Let's talk about energy. It is a term we use all the time, but if we examine it, it's difficult to quantify. What is energy? One definition is that energy is the ability to do work, to move matter. Force times distance. Heat is also a kind of energy. Energy comes in different forms. Some of those forms are, if we think about it, kinetic energy is the organized motion of molecules. Potential energy is the energy of an object's position. Internal energy, that's the energy of chemical bonds. We can harness that internal energy for different chemical reactions. For example, this reaction of hydrogen and oxygen to make water. You've probably discussed kinetic and potential energy in a physics course and how they're related. Potential energy and kinetic energy often trade off, depending on the system. This roller coaster is a great example of trade-offs between potential and kinetic energy. How does heat fit into these definitions? Heat is defined as the energy that flows between two systems having different temperatures. Now, this is a very subtle difference. Temperature and heat are not the same thing. Temperature is an indication of how much heat there is in a system. Temperature is the indicator, heat is the energy. If two objects are brought together, heat will flow from the hot object to the cold objects, and heat will flow until their temperatures are the same. Heat won't flow forever. Once they're in thermal equilibrium, the flow of heat stops. And this is a fundamental statement of thermodynamics. Thermodynamics is a scary word. I promise not to use it again in this lecture. Endothermic reactions, endo and exo, these are important definitions that we use in chemistry. Endothermic reactions absorb heat. In an endothermic process, the system gains heat. A chemical cold pack is a great example of an endothermic process. The chemicals in there absorb heat. Exothermic reactions give off heat. In this case, the system loses heat. Heat packs, the chemicals in there undergo an exothermic reaction. Remember, our reference point is the system. A melting ice cube is an endothermic process. It feels cold to us because we are not the system, we are the surroundings. The ice cube is the system. It is taking in heat from, this case, our hand. So scientists assign units for both heat and work, the same units. The metric system unit for heat and work is the joule. The US system uses the calorie. Wiley gives you problems using both, so that's why we talk about both. We can convert between the two if we have to, using dimensional analysis, and our conversion factor is 1 calorie equals exactly 4.184 joules. When solving heat problems, be sure to use your units. Specific heat. It's defined as the amount of heat necessary to raise the temperature of a substance by 1 degree Celsius. Different materials have different specific heats. The units for specific heat are joules per gram degree C for metric, or calories per gram degree C for the imperial system. Table 3-2 in Wiley gives you specific heat values for different substances. Note that both English and metric values are given, and which value you use depends on which problem you are working. You do not have to memorize these numbers. It is important to note that water, regardless of the unit we use, has a very high specific heat compared to most other substances. You will be using specific heats to solve problems, and in our next video lesson we'll talk about how to set up and solve these heat-related problems. As you watch these videos, do the readings, and practice problems, remember, the main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.